Hi guys, I'm Jayan and I'm going to talk about the contents in this video is about blockchain technology, blockchain data structure and transaction steps in blockchain. Firstly, blockchain technology. Blockchain technology is a shared immutable ledger that facilitates the process of recording transaction and tracking assets in a business network. And assets can be tangible or intangible. Tangible assets consist of a house, car, cash, land, etc. Whereas in other hand, intangible assets as a intellectual properties, patents, copyrights and branding. Virtually anything of value can be tracked and traded on a blockchain network, reducing the risk and cutting costs for all involved. Blockchain was invented by the Santoshi Nakamoto. Santoshi Nakamoto is a pseudonym of an unknown person, which means the name used to protect their privacy currency of their bitcoins. The true identity behind the name remains still unknown. In 2008, served as the public transaction ledger of the cryptocurrency Bitcoin, which made it the first digital currencies to solve the double spending problem without the need of the trusted authority or central server. And now let's move on to the blockchain data structure. A blockchain maintains the continuously growing list of records called blocks. These blocks are linked and secured using the cryptography, and each block contains a cryptographic hash of previous block, a timestamp, and transaction data. The data structure of the blockchain is designed to ensure the securities, transparencies, and immutability of the data it stores. It consists of a chain of blocks where each block contains a list of transactions and linked to the previous block. This creates a tamper-evident record of all transactions on the blockchain, as shown in the figure below here. Blockchain data structure. In blockchain data structure, the structure of the block in a blockchain includes these elements. Firstly, we have block header, transaction data, and nonce. The block header. This contains the metadata about the block, such as the block height, the timestamp, and the cryptography hash of the previous block. And second, transaction data. This is the actual data that is being recorded on the blockchain, such as financial transaction or data records. And finally, the nonce. This random number that is used in the proof of work consensus algorithm to ensure the block is difficult to create but easy to verify. Blockchain data structure is designed to efficient, secure, and scalable. It allows for the efficient storage and validation of transactions. In summary, a blockchain data structure uses the cryptography consensus algorithm to maintain the secure and transparent record of transaction. Here comes the transaction in blockchain. How does the transaction get into the blockchain? As you've seen from this picture, if someone requests a transaction, the transaction broadcasts to P2P computer nodes. P2P means it's the short form of peer-to-peer network. It's based on the concept of declaration, which allows the participant to conduct the transaction without needing the central server. The peers or the nodes, usually a computer, communicates with each other on the network freely without an intermediary. Validation miners verify the transaction. Any miner who has completed the proof of work is permitted to propose a new block that will be added or attached to the chain by referring the last block. The new block is then broadcasted to the network if other network participants agrees it's valid block. That is, a new block added to the existing block, and then finally after the verification the transaction is complete. Types of blockchain transaction. A smart contract transaction involves the execution of self-executing contracts on a blockchain. Cryptocurrency transaction involves the exchange of digital currencies such as Bitcoin and Ethereum. Decentralized finance transaction involves the interacting with decentralized financial protocol and platform that operates the blockchain networks. And non-fungible token transaction involves the buying, selling, or transferring of unique digital assets represented on a blockchain. Blockchain transaction can be verified by the smart contract testing. As I said before, smart contract testing involves the testing the blockchain apps smart contracts to ensure that they execute the transaction correctly. This includes testing the smart contracts codes for error and vulnerabilities that can compromise the security of the blockchain app. And below there is an example that I have executed.